Woohoo, we're live. This is Math 40, Elementary Algebra, and this is Chapter 3. Yay! And to start off Chapter 3, we're going to either introduce or hopefully review the rectangular coordinate system. In other words, we're going to be graphing. So let's get started because Chapter 3 is all about graphing. Woohoo! And I will begin this with I'm going to aim for a middle ground because I know at this point, if you're coming into this class, you've probably graphed before, but you may be a little rusty. But if you're really, really rusty, you probably want to come talk to me, go talk to tutors, find a relative or a friend, have a big math party, invite your friends to help you, but ask lots of questions. And if you're struggling and you're like, I can't remember any of this, just come and let me know and we'll work it out. We can practice on Zoom, we can practice, I can give you lots of extra practice problems, all that wonderful stuff. Graphing is going to be a foundational skill for mathematics. So we don't want to, build a crumbly foundation for the rest of your math classes. Okay, woohoo! Let's get started. So we're going to go ahead and start 3.1, the rectangular coordinate system. And then I said, identify the following on this graph. And I've got some grid paper right there. But before I do, I want to make a little graph so we can focus on a couple of the most important parts. And of course, I'm ignoring this poor ruler right here, which I should be using, but this is just a sketch. The foundation for graphing in the plane or on the piece of paper is a vertical axis and a horizontal axis. And I'll remind you, this is vertical and this is horizontal. And generally speaking, each of them is going to be assigned to a variable. And most of the time in this class, and much of the time in the next class, you will know that the horizontal axis is known as the x-axis. The x-axis is this one. Okay, I'm totally going to Smearyland, I'm sure. The x-axis is this guy right there. And then the y-axis is this axis right here. That's the y-axis. Now we don't write the whole x-axis here. We write x. We don't write the whole y-axis. We write y. But that reminds us, these are going to be the y values. These are going to be the x values. And these lines, and this is my belief, should be written with arrows at both ends, which means they keep going in both directions. This is a small piece of an infinitely long line. Same thing here. This horizontal line keeps going forever and ever and ever. And because of that, we've got arrows. And if you imagine this line going forever this way and this line going forever this way, it breaks the plane, it breaks the paper down into 4 pieces. We call these the quadrants. We start counting here, and then we're going to do something kind of weird. We're going to go counterclockwise. These are the quadrants. And generally speaking, now you don't have to, and I have seen people do it otherwise, but I was taught to write the quadrants in Roman numerals. So this is 1. You can see it's just got 1 line. 2 is 2 lines. 3 is 3 lines. And just to spice it up, 4 is a line, an I, and then a V, which basically means in Roman numerology, no, that's not what I was going for. In the science of Roman numerals, it's 5 minus 1, which is 4. So that's how you write a 4. So you might want to remind yourself that this is 4. So this is 1, 2, 3, and 4. So those are the quadrants. And then there's something called scale. And what scale is scale is the difference between science and marketing. And that is when I go ahead and I write, I'll let that be 1, and I'll let that be 2, and I'll let that be 3, and then that'll be -1, -2, and so on. That's what I mean by scale. Each of these numbers is part of the scale of the graph. Same thing on the x-axis. I'm trying to do pretty even ones. But the difference is when the y-axis has a certain numbering system, the x-axis might have a different one. So you could do 1, 2, 3, 4, or it could be 5, 10, 15, 20. And you may not write all of the numbers in. You might decide that you're just going to write one. For me, for my class, you are required to write at least one number that tells the scale on the x-axis and one number that tells you the scale on the y. Other people have different standards. Mine is just one number. So there needs to be at least one. Now, if you're starting out brand new to graphing, or you're really, really rusty, write all the numbers in. It'll make it easier. When you just kind of summarize like this, it's a lot harder. You spend a lot more time counting. So I would encourage you to do it like this, write all the numbers in, but you don't have to. Okay, next up, rectangular coordinates, Cartesian coordinates, and an ordered pair. So rectangular coordinates follow the idea that starting from, and I'm going to point this out right here. I know this is number 4, so I'm jumping ahead. This point in the middle is known as the origin. That means the beginning. And if we start there, our choices are to either go left or right, or up or down. And when we move, we're going to move left, right, up, down, sideways. Something like that. And because we're moving like this, and we're moving up and down and left and right, we end up making rectangles. We make little rectangles, if you imagine. We're moving along a rectangular set of, well, my brain is just not thinking of words, but basically we're drawing rectangles on this grid. And so that's why it's known as rectangular coordinates. And if I were you, I'd be saying, wait, are there other kinds of coordinates? And the answer is yes, there are. There is a coordinate system called polar coordinates, where you would have the x and the y, or maybe other letters, and instead of drawing the rectangles that we have here, squares and rectangles, you actually draw circles, a bunch of concentric circles. These are called polar coordinates. Kind of like the North and South Pole, right? When you're looking at like a sphere, you've got the circles. These are also known as Cartesian coordinates because the famous philosopher René Descartes, who said, "I think, therefore I am," or at least is famous for saying that. Whether he said it or not, I don't know. I'm pretty sure he didn't say it in English to begin with. But his name was René Descartes, and so it's Cartesian. And just a note about that, it doesn't mean he's the only one that came up with it. It means that he was the one that got famous for it, which isn't always the same thing as the only one doing something. He just was the one that is known for it. So we named it after him. A lot of people just call them rectangular coordinates. And then there's the concept of an ordered pair. An ordered pair is what happens when you write two numbers, and the first number is always your x, and the second number is always your y. And some people ask, why do we start with x and go to y? Well, that's in alphabetical order. So that's one way to remember it. I don't know if you can hear my kitten, but she is very excited about graphing and disappointed that she's in the back and can't come out and graph. So I can write pairs of numbers, a pair of numbers like 0, 0, and then I can know that 0 is x and 0 is y. Or, for example, in the ordered pair -2, 3, x is -2 and y is +3. So we know going into it which order we're going to put them in. You might ask, can I have more than that? And the answer is yes, absolutely. There are ordered triples, there are ordered quadruples, I guess. There are you can make a long line of coordinates. Now, whether you can graphing in 3 dimensions is a little hard because that means you've got another axis. Let's see, how can I can do it kind of like that comes straight out at you, like, a 3D movie. After 3 dimensions, though, it gets harder to graph. 4 dimensions is a little hard. Some people use time or color. And then 5 or 6 dimensions gets really, really weird to think about. So we're going to stick with 2 dimensions just in the paper. And then if you get really excited, 3 dimensions is waiting for you after you get through your first year of calculus. So you got to get through a year of calculus, and then we start graphing in 3 dimensions. So it's coming. It's just going to take a few classes so that you've got enough that you understand about algebra, so then we can have it come right out at you and start graphing, really interesting stuff. Okay, so what I want to do is I want to take all of this information and go over to this graph, this grid, and graph on it. Okay, and this time I am going to use my ruler. Let's see, I wonder if yellow will show up well enough. Will yellow show up well enough? I'm not sure. I'm going to double it with, I'll do yellow and then my pen for my y-axis. I'm just putting the y-axis somewhere in the middle. It doesn't have to be exactly in the middle. And let's see, this was green. I'm trying to learn how not to go what's the word? Smeary Town. There we go. There we go. So we've got our yellow axis. I'm going to put arrows. Now this is, some people do not put arrows. Some people think it's cooler to not put arrows in. And I say that they're wrong. But they are going to go their whole lives just doing it wrong. There's nothing I can do about that. Arrows on the x-axis as well, x-axis, y-axis. For the time being, we're not going to move these around. However, in the future, could this be the y-axis and this could be the x-axis? Yeah. In fact, this could be the a-axis and this could be the z-axis if you wanted. There are a lot of different things we could do. For right now, x and y. Now, I've got a lot of choices here. I'm going to move both pages into the screen so you can see better. The origin is always going to be right in the middle. And the coordinates are 0 and 0, which means you're starting right in the beginning. You haven't gone anywhere. So that is 0, 0. And I will label that when all of our other points are done, because we're going to need some space. Now, I can choose any scale I like. So I could count 2 and make that 1. I'm going to try to keep things pretty simple. So I'm just going to count 1 and make that 1. And that'll be 2. And that'll be 3. And on the x-axis, when I go the other side of the origin, -1, -2, -3. On the y-axis, when I go up, it's 1, 2, 3. And when I go down, it's negative. -1, -2, -3. Hopefully you notice that this is a number line. The x-axis is just a number line. And in fact, the y-axis is just a number line that has been, it's doing a handstand, right? So it's just standing up in a vertical fashion, but that's a number line as well. Okay, so there are 2 ways to look at graphing. There we go. If I want to graph number 5, -2, 3, let's see, I need some colors. Hopefully it won't be too confusing if I make this the blue one. -2, 3 tells me that x is -2 and y equals 3, because they're always written x and then y. So x is -2. So on the x-axis, I find -2. And y equals 3. So on the y-axis, I find 3. And then I move towards each other and I find the point. See how they both, this is where y equals 3. This is where x equals -2 right there. And this is the point, -2, 3. So far, so good. Now there's another way to do that, and that is to do it like you're walking. So I say x is -2, y is 3. So I walk over to -2, that's left, and then I move up to 3. 1, 2, 3. So I do it as two different paths, or I do it all at once. You can choose whichever way makes more sense to you. So that's the blue point. Okay, what colors do I have left? Pink. -2, -3. So x equals -2, y equals -3. So I'm going to go over to -2 in the x direction, and then I'm going to go down 1, 2, 3. There's -2, -3 right there. Oh, I went to Smearytown a little bit. Sorry about that. Okay. I'm running out of colors. The next one is the 2, 3, or just 2, 3. X equals 2, y equals 3. Okay. I'm going to go over 1, 2, and then up 3. Or else I'm going to say x is 2 and y is 3 and find where they intersect. 1, 2, 1, 2, 3. There's 2, 3. There we go. Okay, and what color have I not used yet? Oh, I haven't used orange. Okay. And then the last one, 2, -3. That will be x equals 2, y equals -3. And you can kind of guess. The great thing about mathematicians is we are very consistent. But where do you think the point's going to go? And if I say that, then you would say, oh, well, how do I say over here? And the answer is, well, here's the first quadrant. Here's the second quadrant. Here's the third quadrant. Here's the fourth quadrant. So you could say it goes in the fourth quadrant. And a quadrant is a fourth, right? It's the 1 quarter, 1 quarter, 1 quarter, 1 quarter. So it goes in this piece of the 4 pieces. And you're right. If x is 2 and y is -3, I go x gets to 2 and then y goes down. And so there we are at 2, oops, Smearytown, 2, -3. There we go. Okay, what do you think so far? Hopefully this is you know, gently pushing open some doors in your memory, knocking off a little bit of dust. Your brain's going, oh, I remember this. So something that you might not have learned, but we're going to start talking about it now, which I think is awesome, because normally we're supposed to wait until there are certain things we tell you now and certain things we tell you later. And the idea is if we told you everything at the same time, it would be too much. But this is a really good thing to know about. We're not going to use it as much, but you have used it a teeny tiny bit. You use this a little tiny bit when we talked about the intervals with the inequalities. And that is that if I grab my pen, and if I hold my pen with a closed fist, the pen stays there. Now, what happens if I open my fingers? If I open my fingers, the pen falls out. So, an open point is drawn as an open circle. And it does not include that value. So the point is not included. Ooh, I'm trying to draw right sideways. A closed point means that we fill it in completely, and that means that the point is included. Now, for the most part, we're going to be using closed points. So you notice, and hopefully I made these very extra careful. I made them extra big so they're visible. But do you notice how I went to trouble of coloring these all in? These mean these points are there. Now, why would we need to draw a point that's not there? Well, that's a very good question. That is kind of silly. Like, okay, we need to know how to draw points that we don't that aren't there? And the answer is sometimes it would be a boundary. Sometimes it would be the limit or the fence for something else. So a lot of times what you would see is you would see like something that looks like this. It looks like a barbell, an open point and then a line and then or a line segment and then another open point, which means everything in the middle, but not the two ends. So sometimes that comes up in math. So if it does, we've got it. We're ready. Okay, let's do a couple other things. So the next thing is, and here I would encourage you, go ahead and take a look at all this and make sure this makes sense. You can remember, you can always pause videos. I'm sure you know. At this point, we've gotten to 20 minutes. You may have already paused me because you're like, oh man, this is a long video. This one, the introduction is going to be a little bit long, but we're going to get there together. So what I'd like you to do is go ahead and pause the video and then go ahead and figure out what the coordinates are for all of these values. And I will wait for you. I'm waiting. Here, Godzilla will come in and say, it's time to pause the video. Okay, are you back? Woohoo, yay! And some of you didn't even pause the video, and that's okay. We're gonna go ahead and I'm gonna give you the coordinates of each of these points. We got A, B, C, D, E, and F. And I'm going to go ahead and write in the parentheses for each of these. Now, if I were you, I'd be looking at this going, how are we going to know these are points and not something else, like an interval or something? And the answer is context. Yes, I am completely with you. There were very few symbols that people were using, and they were using them for everything in math. And if I had been around at that time, I would have tried to stop them and said, hey, this will be confusing. In the year 2020, when everyone is sick or trying not to get sick from this terrible virus and we're all stuck inside, this is going to be very confusing for math students. And if I said that, they would have burned me at the stake. So it's probably wouldn't have helped at all. Okay, never mind. Let's go back to this. Okay, so I personally find A a little bit intimidating because it's right there on the x-axis. So I know that for A, we're at 1, 2, 3, 4, 5. I can see the number 5. And you have to remember that the numbers that are on the horizontal are the X. Horizontal comes before vertical in the alphabet. So horizontal comes first with X, vertical comes second with Y. So 5 is the X coordinate, but the question is, what's the Y coordinate? Well, if you're not up and you're not down, you're at 0. And some people ask, what quadrant is this in? And the answer is it's not in any of the quadrants. It's on the boundary of 2 of the quadrants. It lies between the first quadrant and the fourth quadrant, just on the x-axis. Okay, what about B? So let's look. B is right there. So I see close to that is the number 4, but I see that's written in the y direction. It's 4, 1, 2, 3, 4 squares up. And if you count from the origin, it's 1 square to the right and 4 squares up. So that's going to be 1, 4. What do you guys think? Woohoo. Okay, C. We got to find C. C's over here. Start at the origin. I go 1, -1, -2, -3, -4, and then I go down 1, 2, 3. So I'm down at -3 in the y direction, at -4 in the x direction. Okay, let's look for D. Either D is the hardest one or it's the easiest one. So D is at the origin. Woo! So that's 0, 0, origin. Woohoo! E is way out here. And notice that they've done something kind of nasty. There's no number. There's no number. So we're going to have to either count or guess or however you like to do it. I'm gonna go ahead and count it out. 1, 2, 3, 4, 5. I'm in the negative direction. And there should be arrows here. Let me fix that. So I go -1, -2, -3, -4, -5. I'm on the x equals -5 line. And I go up 1, 2, 3, 4, 5. I went up, so it's positive 5. Okay, and the last one is F. And that one is really nasty. Now here is the downside of being human. and not say like a computer. And the downside of being human is that we can't tell, our eyeballs can't tell exactly what that is. So you can guess. I'm going to say I move from the origin, I go to 1. It's not quite as far as 2, it's about halfway. So I'm going to say it's about 1.5 over to the right. And then as I go down, I go to -3. It's about halfway between -3 and -4. So I'm going to say like -3.5. What do you guys think? Now, if you think it looks more like 1.4, awesome. There's a lot of flexibility here. And the only way we could get more specific is if we understood more about what this problem comes from. We're just seeing these points, but if there are equations or problems that these refer to, we might be able to get some more information that would help us. So this is just going to be an estimate. Woohoo. Okay, one more. I know you guys have made it through a very long video. Ugh, and it's a word problem. Oh no. So basically, this is an interesting word problem. I just Xeroxed it right from the book. This is the following graph that gives the heart rate of a woman before, during, and after an aerobic workout. So here we go. We're down here on the graph. I've written time. Well, they've written time in minutes. So notice that we can actually go to negative time. And so my first question would be, what's negative time? What is negative 10 minutes? That's awesome. Well, in this, I think what they mean is it's 10 minutes before the woman started. So, and you see, and this is unlikely. I mean, to be honest, most of us don't have a perfectly flat heart rate, exactly 60 beats per minute until you start moving, but it's possible. So 60 beats per minute. And then what happens? Starting at time 0 and going all the way up to, and here if I draw a dotted line to make it easier to see, up from 0 to 10 minutes, they're warming up, and notice that their heart rate is increasing to 140. Okay, then they're training, and this is like an Olympic athlete. They got it dead set on 140. I am very impressed. Even when I'm on a treadmill holding onto the thing and watching it, it goes up and down. You know, it wiggles around a little bit. So this is very impressive, very flat. So they're training between 10 minutes and, let's see, 40 minutes. So that's a half-hour workout from 10 to 40. And then cooling down, you can see that their heart rate is coming back down. Okay, so that's kind of interesting. So it says, what was the woman's heart rate half an hour after beginning the workout? Now, I picked this so we could discuss how frustrating word problems can be. So does it mean is 0 when they begin the workout? Or does the warm-up not count and the workout begins at 10 minutes? I'm not sure. So we just got to make our best guess. Sometimes word problems are really frustrating in that way. So half an hour. So half an hour equals 30 minutes. So if we go from the beginning is 0, 30 minutes would be right there. And that point corresponds to 140 beats per minute. Now, just to make it interesting, let's see what happens if we counted from 10. Half an hour after 10 is 40. And notice her heart rate is also 140. So it doesn't matter whether you thought you start at 0 or at 10, you get the same answer, which is really nice. So even though it is not a clear question, the answer is clear, which is interesting. For how long did the woman work out at her training zone? So I'm going to go here. It says warming up, training, cooling down. So this is the training zone. And so the question is, how long is this? And that's something I even mentioned when we were looking at this. This is part B. And it says this goes from 10 to 40. So either you can just do the subtraction, 40 minus 10 is 30, or you count. I see I've got 10 to 20. So that's 10 minutes, another 10 minutes, another 10 minutes, 10, 20, 30. Woohoo. Okay, so hopefully What we've done in this video gives you enough to get a good start on the homework. As always, if it's frustrating, if you don't understand something, if you just want to say hi, come say hi on Pronto. Come to office hours. Ask questions, look up the tutors, find a tutor that you really like to work with, get some free tutoring. That's pretty awesome. Ask your friends, ask your family. What a great way to start a conversation with a random person on the bus if we ever get to ride on buses again. Woohoo! Have a good day. Enjoy the homework. Math on, guys.